Now that we have defined the major arc and the minor arc for the circle, now comes the discussion of a special case called the diameter. If I have a diameter for the circle, how do we try to take into consideration the arc connected with the diameter is what we are going to investigate in today's session. This session is about investigating the arc for the diameter of the circle. Diameter versus arc. In order that we understand the arc connected with the diameter of the circle, let's take a circle connected with the diameter. As we all know that a circle with the diameter just simply has a line passing through the center of the circle. I have a circle with the diameter. Suppose I have the diameter out here. Is how we connect. Now this circle assumed as a pizza, I would like to cut the pizza along the diameter. So I just try to cut the pizza in this diameter direction. So clearly I get two slices of the pizza. So here I get slice 1 and slice 2. So here is the first slice and here is the second slice. Now with these two slices of the pizza, I have the center which is common in this case. So what do we observe from the arc as obtained here and the arc which is obtained in the other piece of the pizza? So clearly I see that for this pizza, cut into two pieces, arc 1 is the arc obtained for the first pizza and arc 2 is the arc obtained for the second pizza, and clearly they are equal because this line exactly cuts the pizza into two equal pieces and therefore we get two equal length of arcs, which makes us conclude that when we take the diameter into consideration, the lengths of arcs obtained by the diameter of the circle are always equal. That is, when I take the diameter, this arc length must be equal to this arc length, is how we conclude. So, the arc lengths, the arcs obtained by the diameter of the circle, the arcs obtained by the diameter of the circle are always of equal lengths. So this is one of the investigation concluded that if the arcs obtained by the diameter of the circle are always of equal lengths. Is how I conclude the conclusion. Diameter makes the two arcs to be equal. So here arc 1 equals arc 2. Is how we conclude for two pieces of pizza. This defines two equal pizzas. Arc length of this pizza equal to arc length of this pizza. And also, it's very important to note that this semicircle, when divided along the diameter, forms two semicircles. So this circle, when divided, forms semicircle 1 and semicircle 2. Is how we conclude the diameter connected with the arc. Now that we have discussed a special case of the diameter and the circle with its arc, a diameter defines equal lengths of arcs for a given circle, is what we have concluded. Now comes the discussion of semicircle. Let's see how a semicircle is defined through the diameter for the circle. Semicircle versus the circle. So the word semi itself says exactly half of the previous circle. So semi is half of the circle. Therefore, if I take a circle then half of it is a semicircle. So clearly, when I pass through the diameter, the center lies out here. If I cut the circle along the diameter, I get a semicircle, is how I understand the semicircle. So here, this is a circle and this is a semicircle. For the circle and the semicircle, let's see the lengths of arcs, how the arcs are defined. So for this, I have two arcs which are formed along the diameter. This is arc 1 and this is arc 2, which are of equal lengths. So let me say the length of this arc is L. Then because the first arc is equal to the second arc in the diameter passing through the circle, therefore the length of arc being L also makes this to be L. And as we have seen, a semicircle is nothing but exactly half of the circle, so this length must be equal to this length. So clearly we see that each of the arc lengths are equal. Therefore, a semicircle is now defined in terms of the arc length. So let's see how we can define a semicircle for the given circle through its arc length. A semicircle is a part or piece of the circle whose arc length is exactly half of the circumference of that given circle, is how we understand a semicircle. A semicircle is a part or piece of the circle whose arc length is exactly half of the circumference of the given circle. So if the circumference of this circle is say L or 2L, then the arc length of this semicircle will be L, because half of the total 2L is L. So given the circumference of the circle, a semicircle will have its arc length exactly half of the circumference of the circle, is how we understand the arc length connected with the semicircle for the given circle. Semicircle versus circle versus arc length.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.